Hey everybody. So let's finish up this unit, and the last thing I wanted to talk about is just how this works in code. We've covered everything for transformations, at least until we get to 3D. So I want to talk about how this works in OpenGL and processing. The transformations in OpenGL and processing. Luckily, it's pretty much obvious, okay? But there are a few gotchas that will confuse you if we don't go over this, okay? So let's talk about first matrix management. How do we manage those matrices in OpenGL? Yep, we understand. How do we manage our matrices? And again, mostly this is obvious, but there is a gotcha. And the gotcha is that, and we've mentioned this before, but this is where we really see it. OpenGL is stateful. That means it remembers what you do to it. Okay? This is really important. Okay? If you change the state, come on. If you change the state, okay, it applies everywhere. So you have to be really careful. Just like we talked about with the matrices, if you modify the matrix, it applies everywhere. Well, that problem, that statefulness, is not just with those matrices, as you'll see here. And pretty much the only spot where this matters is this first command I'm going to show you. GL matrix mode. Okay, GL matrix mode. This basically tells OpenGL which matrix we're working on. So which matrix the commands that we give apply to. Okay. And I'm gonna just to make it easier for you guys later, put it in different color. Then you can easily find them easier in the code, in the notes rather. And you can set this to be either the model, the view, or the projection. And in most implementations, actually, this becomes the model view matrix. And it's actually not so bad because the camera comes, yeah, you just combine the model and the view at once, so it's really not a big problem. So you might have noticed I paused there because I suddenly confused myself, but I actually went and looked up and caught up with myself to make sure I wasn't as confused as I thought I was, which is always good, and I'm not, so that's good. So the model view matrix is often combined, which actually works. It's not as big of a deal as you might think, because what happens is, if you recall from earlier in the notes, if I have my point, I multiply with the model first, then the view, and then the projection here. And so you just if you combine these two into the model view matrix, you set up your view matrix on the matrix stack that we talked about, and you leave it there, and then you just apply your model and you modify the model component. So you set up your view, you leave it on the stack, and with your pushing and popping, you just don't break it. You just don't break it, and you leave it. I leave the view set up, and you can use it that way. Okay, and you just modify you modify the model part of that matrix, and you still multiply it by your point to get your point that's in 3D space. So that's maybe a bit quick. You can come back and look at it if you ever need to, but combining the model view is not really that important because you can set up the view, leave it on the matrix stack, and just modify that model component of it. So that's your matrix mode. So back to where I started, OpenGL is stateful, and you're going to set your mode to one of these, and then any command you give will modify that matrix. So OpenGL is stateful. If you don't know what mode you're in, you don't know what your commands are going to do. Now on the left here, I'm going to actually, in parallel, put the processing equivalent. And here in this case, we're very lucky because in processing, we don't have a matrix mode because processing is always in model mode. So if you're going to do it in processing, you're just always modifying the model and the view and the projection. You can modify them with other specialized commands. I'm not going to get into it. You can go look at the reference page. So you don't have to worry too much about the matrix mode command if you're doing processing, but when you're doing real OpenGL, you need to know what mode you're in. Now, the next command I want to talk about is GL push matrix and GL pop matrix. And these we've already learned about, right? But what's important to know is the first thing is it acts on the current active mode, matrix mode. Okay? So if I'm pushing and I'm set my matrix mode to model view, it'll push the model view matrix and it won't bother with the projection. If I'm in matrix mode projection, then it'll push the projection. So this is stateful. Which matrix this command acts on, you set with the matrix mode. It's stateful. It's kind of frustrating. Okay? The other thing that's important to know is that each mode has its own stack. So that's kind of nice. If I'm pushing and popping in the model view and I switch over to projection, I don't worry about it. It has its own stack, okay? So that's actually quite nice. So you don't have to worry about those bleeding over to each other. Now in processing, we just call these push matrix and pop matrix. Now in processing, it's also stateful, but you don't have to manage it because you're always in model mode with processing, so it always just pushes and pops your model. Okay. Another command that's useful to know about is GL load matrix. Now what this does is it'll replace the current matrix with whatever you specify, whatever data you specify. Replace the current matrix by the one specified. Now I'm going to put one asterisk. Actually, we'll get two asterisks in a second. The first one here is just be careful, okay? Because the order that you specify the parameters in, row major, column major, you need to make sure you read your documentation. It might not be you might get it backwards and you'll be all kinds of confused. So just check the order that you specified the matrix, like which parameter, the matrix elements, the floats, what order you put them in really matters. And it's typically a place that people get confused, okay? So be careful there. Now, the other thing I wanted to say here is that we don't have this in processing. They didn't give it to you, but I'm going to put another red star because I'm going to come back to it in a second of how we do that. Good. So the next one, we have push matrix, pop matrix, load matrix. The next one I want to talk about is GL load identity. And this is exactly what you might think. It'll replace the current matrix by the I matrix. Great. Okay. And then in processing, this is just reset matrix. So you can load the identity and start over, but it's okay because you can always push and pop, and you're not going to lose if you push it first, right? You push your matrix, you load the identity, you do something, you pop, you go back to where you started. It's no big deal. The next one is GL Malt Matrix. And this one right multiplies the current matrix by the one specified. Okay, and by right matrix, of course, by right multiply, of course, we mean that my current matrix is going to be equals, well, whatever it was before, multiplied by this new matrix. So you multiply on the right, not on the left. So you right multiply it. It builds up. This is really important to know because it specifies the order that your operations will happen in. Now this in processing is apply matrix, which I think is a terrible name. Apply, what does that even mean? How about multiply matrix? So you apply the matrix. Now the reason I'm going to come back now to this. So you can't load the matrix in processing, at least not that I'm familiar with. So what you do is you can load the identity and then apply the new matrix. So you load I, multiply it by your new matrix, and you have it loaded. So if you want to specify your own manual matrix, that's one great way to do it. All right. So that's pretty much it for matrix management, okay? So with these commands, this is basically all you need to manage the matrices in OpenGL. Now quickly, I'll go over the transforms that we've learned. And these act just as you expect. The only really important thing to pay attention to is that all of them, they will right multiply the current matrix. Okay, so if I'm given, just like above, if I'm given a transform M, then the current matrix is going to be the old current multiplied by my M. We multiply it on the right. Okay, so then in processing or in OpenGL, they're all the same thing. If we rotate, okay, what it'll do is it'll calculate that rotational matrix that we learned, then it'll multiply it by the current matrix. So it does those two steps. It makes the matrix, and you multiplies your current matrix by it. So it actually becomes active. So it doesn't return a matrix and then you use it. It does both in one. Okay, so we rotate. Same with translate. It comes up with that matrix, and then it multiplies the current matrix, okay, by that. Right multiplies. And we have scale, okay, and we have shear. So basically, all of these work as expected. They calculate the transformation and right multiply. I'm repeating that again to the current matrix. Now in OpenGL, the current matrix means whatever mode you're in. In processing, you only have the one mode, so it's always to your model matrix, okay? Now a couple of key points. Shear, this is processing only. I basically told you it's useless and nobody uses it. Yeah, OpenGL doesn't even give you a function. If you want to shear, you build the matrix yourself, you load it in, and you do it. It's not hard, it's just no one does shear. Now the other thing I want to highlight is this rotate. This is axis. These are basically the rotations we've already learned. Rotate about the, not about, it's around. What am I thinking? Rotate around the axis, X, Y, or Z, axis-oriented rotation, and you might be thinking, okay, what's the big deal? Well, the big deal is that kind of sucks, and there's a big problem there. So I'm just going to say to be continued. There's a better way to do rotations. That's actually quite complicated, and nobody likes it. But there's a better way to do rotations. But the OpenGL one and the processing one, they're axis-oriented. Axis, you rotate around the x-axis, the y-axis, or the z-axis. You rotate the world, okay? And you can specify that. All right, that's it. This is how you do transformations in OpenGL and processing. Thanks.